Hello and welcome to another video. In this one, we're going to be talking about the assret incident, or yeah, that's what I want to call it. Anyway, let's jump into it. So it's a bit of a long story. We're going to be starting with name tuple. I promise this is related. We'll get to the assret at the end. So this actually came up on my stream recently, and I thought it was a pretty instructive design description about how Python has made a mistake a few times, but also fixed it in other ways. And so let me walk you through that. So in Python, there are several things to create classes. One of them is nametuple. Nametuple has a bit of a problem. Let me just show you the old nametuple, because both old and new nametuple have the same design idea, but this obviously came first. And the way nametuple works is you call named tuple with a class name. So let's say our class name is D, and you can pass it a list sequence of fields. So say it has A and B. I don't know. Let's use a more reasonable example. We have a point which has fields X, Y. Usually assign that to a name and close your parentheses. And now you have a point class that automatically gives you positional arguments, named arguments, etc. Allows you to have a point class. Now, nametuples also have a few other functions that come out of the box on them. So if we assign an instance here, there are a few methods, and you'll notice that all of them begin with an underscore. For instance, azdict, it allows you to convert a point in a dictionary. There are a few others here as well. Azdict, there's replace, there's fields, there's field defaults. All of these are underscored. So the question was asked me, why are they underscored? Why, usually underscore means private, but these are intended to be a public interface. Look at azdict here. Mention it in the docs? No, they don't. They probably mention it somewhere, but the point of this, here it is. To prevent conflicts with field names, the method and attribute names start with an underscore. So Python has sort of intentionally avoided any user space names, such as the ones that you might want in a class, by putting an underscore in front of it. In a way, they've created a namespace using the underscore. And so this is kind of a little bit of a wart, I would say, in that it's an unfortunate situation where you have to break your normal conventions in order to avoid potentially breaking user code where they could have arbitrary names namespace. And the final example that we'll get today has the same problem, or a similar related problem, of putting things in a namespace where something might exist, and leads to the assret. But let's talk about a situation where Python got it correct, or I guess more specifically, it got it correct with adders, and then data classes copied as words. So data classes, very similar to nametuple in a way. I actually don't like data classes myself, but little rusty on them as well. Data classes dot data class. So what a data class does is it's very similar. It's a class generator, but you use type annotations to tell it what the things are. So if we point, and there's also a form of nametuple. I think this is how it works. I don't know. I don't really use data classes at all. So now we have another point class, and similar to before, we can construct it positionally, we can construct it with named. It has some differences. I don't have a video on data classes, but trust they're similar, and class out of this. Now, if we look at the of this instance, you'll notice that we just have X and Y. We don't have any of those underscored functions. We do see a little bit of implementation details here where there's a double underscored one, sort of reserved by Python, but you would never call these directly, particularly what you want. In fact, some of the information is notations, etc., etc. So what data classes does is it separates those sort of would-be methods outside of the class and instead provides them as module level functions. So where you would have previously, I clobbered the name. Where you previously would have done inst._ fields in data classes, it's data classes module. That's a function called fields. Pass in the instance here, and it gives you back a list of the field objects. I guess implicitly these get converted into data class fields because they're types, defaults. I don't know why the repr looks so gross here. Like, probably should be spaces here, but drugs, not my problem. Maybe that'll be an easy patch for one of you viewers watching to go contribute to CPython, improve this repr a slight little bit. But anyway, the point here is that you'll never collide with the user namespace, the places where someone would put their own attributes here. And so this allows you to do things like have underscored fields. So add a point to underscore x as underscore y as in. Now, I don't know why you would do this, but there's probably a reason, and this works just fine. The class is fields, point to, see here that we're allowed to have underscore. Whereas with name tuple, if you try to do the same thing, to x, y, these are not allowed because they would pollute with the namespace that Python set. So a cool little design pattern, the point being, like, if you can take arbitrary namespaces from a user, you should probably separate your functions out so they don't pollute that same namespace, so you don't have to do weird hacks like underscore people. I really like this design. There's actually a JavaScript mocking library that does this same. So I haven't used it in forever, but I'm pretty sure they follow the same design pattern here, where the mock objects themselves are just sentinels, and then the actual, oh no, this is, I feel like it used to be that way, where they didn't put it on this. This probably suffers from the same problem that we're about to talk about. But anyway, let's get to unit test mock, and that brings us to the assret incident. So we actually have to go back to Python 3.4 to demonstrate this problem. I don't have it installed, so we're Docker. And if you don't know about mock objects, they basically allow you to stub out or replace an object with a fake object, or a really, really fake object. For instance, mock, and we make a mock that mock. This is a mock object. It's callable. It's callable with arbitrary arguments. It's callable with arbitrary keyword arguments. It's attribute assignable. It's basically a squishy object that you can shove into anywhere, and it mostly does well, it does nothing, but sort of exists inside the same previous object. You can also use mock to patch out stuff. So if we did like I don't know, with mock.patch.object os get pwd return value equals wat print os.p, it allows you to safely temporarily patch functions. I mean, safely. There's nothing completely safe about patching out a function, but it allows you to do it with a context manager, etc. Okay, but that's, you know, I'm not going to talk about the mock module that much today. We're more interested in mocks themselves. And I mentioned that mocks have the same namespace problem that name tuple does, in that if we look at our mock object here, dict? No, not dict. You'll see that there's a bunch of functions here. There's also the attribute that we assigned earlier, but the important part is there's a bunch of functions here, and these are all used to write assertions in tests. You notice here that assert called once with, assert called with, assert has calls. These are all things that you would want to do in your test to check that you got called correctly. So I think a lot of these functions are smells myself, and I try to avoid mocks as much as possible. But these are, you know, they do get used. So for instance, if we, let's remake our mock, because I called it with, we pass m12, and then we do m dot assert called once with 1, 2. It returns none, so our assertion passed, and something that fits in your. Now, unfortunately, if you make a typo in this, and this has sort of been fixed, make a typo in this, maybe you think like, oh yeah, assert called once with is there, maybe assert called twice with is there. You know, maybe it's Ruby where they do funky special attribute lookup and make that all magically work. But you'll notice here that it just returned another mock object, rather than failing or raising an assertion error or something like that, or an attribute error. It just returned back another mock. This was a really, really common mistake in tests, that you would write a test, you wouldn't check that it failed, and it would be silently passing because it was just getting back another mock attribute, because mocks have attribute access infinitely for whatever attribute you specify, unless you use a spec set, but spec sets here. And so any sort of typo in this function would cause your test to silently pass. And again, this is because the namespace is stuck in this mock object itself rather than being free function somewhere else where you would actually call them on a module, pass in the mock instance, and then divorce these two. And so this is a problem. So how did they go about fixing it? And that is where assret play. They added a special attribute to mocks in Python 3.5 called unsafe, which I don't like the name of this because there's nothing really safe about mocks and there's nothing really unsafe about using mocks. I don't know. I feel like anytime somebody calls something secure, safe, fast, like you should be immediately suspicious of whatever it is, and that's usually where the security or performance problems actually live. But anyway, they called it unsafe. Too late to change it now. What unsafe does is, if we look at modern Python, so 3 from unit to mock, equals mock. If we take that same example from before, where we call it with twice. So if we assert called twice, we now get an assertion error. It says assert called twice with is not a valid assertion. Use a spec for the mock if it's meant to be an attribute. Oh, nice. Here's another opportunity for you to improve Python if you want. There's a little typo in this error message. Yeah, go viewer, fix the typo. Did you mean assert called once with? No, I didn't, but mostly just demo this. So now we get an assertion error, and interestingly, the way the assertion error works is it looks for the beginning of this string. And so that is where we get assret from. This was one of the specialized names. I don't know why it was just assert and assret initially. There's actually a bunch more now. Like, I don't know. There's a few other permutations of this that, well, we already know assret. I don't remember what it is, but there's a few other permutations in here that I guess assret in there. I don't think it is. Anyway, there are a few more now, but the initial commit only had these two, and that's highlighted. But anyway, hopefully this is a little bit instructive on if you somehow need to make a class generator or a generic namespace representer to maybe take some historical reference from the mistakes made in name tuple and mock, and maybe take some learnings from adders and classes, separating out framework methods from the actual true space. And on here. Hopefully you found this useful. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.